there. My name is Dr. Tasha Stanton, and I work as a clinical pain neuroscientist at the University of South Australia. My research tries to better understand why we hurt, why we feel pain, and what affects how much pain we feel. I understand that today, you did an experiment that involved sticking your hand in freezing cold water. You might have noticed that what you experienced was quite different to what some of your other classmates experienced. Maybe some of you didn't find it very painful at all. Maybe some of you found it super painful and had to pull your hand out almost immediately. But why would this be different for different people? You were all sticking your hand into the exact same ice cold water. Experiments like this tell us more about how pain works. When you put your hand into the ice cold water and feel pain, you haven't damaged anything, have you? No, you sure haven't. So this tells us the first thing about pain. Pain can tell us about tissue injury or damage, but many times it tells us about things that could be damaging to us. It's an alarm system that lets us know when things aren't quite right. And in this case, when we need to pull out our hand out of the water. And that's the key thing. By acting like an alarm system, pain allows us to change what we're doing before anything goes wrong. It's a protector. But that doesn't answer why different people felt different things. This comes down to how complex pain is. Did you know that it isn't just the danger signal that's coming from your hand, going up your nerves to your spinal cord and then up to your brain that matters to the pain you feel? One of the biggest things that influences the pain and how much you feel is your past experience. And for things like cold water, guess what matters? Where you live. People who live in the Northern Hemisphere where it's super cold, like Canada, where I'm originally from, tend to not find the cold water task to be as painful as those people who live near the equator, where the weather tends to be quite warm. And people who live near the equator don't find a hot temperature task to be as painful as people who live in the Northern Hemisphere. But this still doesn't explain why we might see different things between you all, and because you're all living in Australia. The catch is, it isn't just one thing. It's many things. It can be your genetics. Well, it's rare. Some people can't feel pain. It can also be how scared or how anxious you feel about something. This can increase pain. Having other health problems can make things more painful. And if you think that something is going to damage or hurt you, it can make something hurt more. But even within a person, pain can be different at different times. If you are taking painkillers, the same thing hurts less. But guess what? If you're taking a strong painkiller, it will work better if we tell you that you are receiving the painkiller than if we give it to you, but we don't tell you. And there are a lot of things that you can do yourself that can change how much something hurts. If you're distracted, like playing a really awesome video game, you might not feel as much pain when you're sticking your hand into ice cold water. And people who learn to meditate, they can often make things hurt less when they meditate. And even changing what you think or believe about pain can make the same thing hurt less. Aren't we complex? One last thing before I go. When you stick your hand into the ice water, you might have also noticed changes to your other hand that wasn't in the water. That other hand can sometimes feel a bit cooler to you. This is because blood flow is reduced to both sides, even though it's only one hand in the water. This occurs to keep you safe. Your system presumes that if one hand is that cold, it probably isn't too long until the other hand follows. So it protects you ahead of time. And what do you feel if you put your cold hand into lukewarm water afterwards? That water can feel burning hot, even though it isn't. Your body actually adapts to things very quickly, meaning that when you experience a big change in temperature from ice cold to lukewarm, the setting of your alarm system has changed. It's in super sensitive mode. It knows your hand has just been numbed by the ice, so it's better to be safe than sorry and make things feel hotter than they actually are so that you don't hurt yourself. I hope you enjoyed this cold water experiment. I always think it's fun to learn more about why we feel what we do. That's why I'm a scientist, and today you are one too. See you later.